We are at HiFLEX Forging Works, a leading steel forging manufacturer. The manufacturing process commences with a substantial stock of 700 to 800 tons of diverse materials, ranging from 150 millimeters to 600 millimeters in diameter. The advanced laboratory system on site supports this operation, and 18 bandsaws of various sizes, equipped with state-of-the-art technology, assist in material preparation. Production is driven by two 12-ton oil furnaces capable of reaching temperatures up to 1,300 degrees Celsius. These furnaces facilitate a 5-ton belt drop hammer and two hydraulic presses with capacities of 1,500 tons and 3,000 tons, respectively. Additionally, 3-ring rolling machines, spanning from 300 millimeters to 3,000 millimeters in outer diameter, offer versatility in profile rolling. Automation plays a crucial role in operations, with fully automated control systems enhancing precision and efficiency. A 6.5-ton ingot hammer ensures a daily production rate of 20 to 25 tons. Within the heat treatment facility, an electric furnace with a 10-ton capacity provides hardening, tempering, and annealing processes, complemented by water quenching capabilities. Machining and finishing are executed with precision on 20 VTL and CNC machines, ranging from 300 millimeters to 3,000 millimeters. Rigorous inspection processes include quality checks, encompassing hardness testing, ultrasonic testing, and tensile and yield reports. In this part, we will explore the manufacturing process of automotive and industrial bearings at VMO Bearings. The first step in bearing manufacturing involves using high-quality bearing steel to create bearing rings. These forged bearing rings undergo a specialized heat treatment process called spheroidizing annealing. This process improves the ductility and toughness of the material while reducing hardness and strength, resulting in a specific microstructure conducive to bearing performance. CNC turning. After the annealing process, the bearing rings are sent for CNC turning. Precision in this phase is crucial for the long-term performance of the bearings. Heat treatment. The heat treatment process is essential for enhancing the durability and longevity of the bearings. It consists of hardening, supercooling, and tempering, which give the bearing ring structure the required strength and stability. Grinding process. Grinding is one of the most critical processes in bearing manufacturing, as it ensures the bearing's accurate dimensions. The grinding process is carried out using fully automatic machines, including surface grinding machines and centerless grinding machines. These machines are equipped with in-process gauges to maintain precise tolerances throughout the manufacturing process. Superfinishing. After grinding, the rings undergo a superfinishing process on CNC super finish machines. This step ensures the best possible surface roughness values, contributing to the bearing's overall quality and performance. Quality inspection. Quality control is a continuous process throughout manufacturing. Each bearing ring undergoes visual and size checks in the inspection room. Only components that pass stringent quality tests proceed to the assembly stage. Assembly. Assembling the bearings is a crucial step where various components, including the bearing rings, rollers, and cages, are brought together. High-quality cages are manufactured in fully automatic cage manufacturing units to ensure the best possible quality. Packaging and dispatch. Once assembly is complete, the final products are packaged efficiently in an automatic packing department, with a capacity of packing 5,000 pieces per day. Proper packaging ensures that the bearings are protected during transit. The manufacturing process at Schaeffler's Savli plant is synonymous with uncompromising quality control and intricate procedures. From the meticulous heat treatment, precise grinding, and honing of both inner and outer rings of roller bearings to the intricate assembly process, every step is executed with unparalleled precision and unwavering attention to safety protocols. The Savli plant specializes in crafting deep groove ball bearings and large-sized bearings renowned for their exceptional reliability in critical applications across various sectors. These bearings are the epitome of Schaeffler's commitment to producing components that meet the most demanding industrial needs. Quality assurance is paramount at Schaeffler, and this ethos extends to its Indian manufacturing operations. Stringent quality testing for products manufactured in India mirrors the same rigorous standards upheld in Germany. This ensures that products leaving the Savli plant not only meet but consistently exceed stringent quality benchmarks. To maintain these impeccable standards consistently throughout the production process, Schaeffler India regularly conducts rigorous quality checks at various production stages. Zen's automatic bearing assembly line is a masterpiece of modern engineering, producing high-quality bearings with precision and efficiency. The process unfolds in several critical steps, starting with the feeding of the essential components, the outer and inner rings. These rings are subjected to meticulous measurements to ensure they meet exact specifications. Simultaneously, advanced sensors and measuring devices assess their dimensions. The selection of bearing balls is a crucial phase, with automated systems meticulously picking and inspecting each ball to maintain high-quality standards. Next, the rings are aligned and temporarily assembled, with automated machinery ensuring perfect fitment. The selected balls are then carefully placed within the assembly, evenly spaced to guarantee uniform load distribution and low friction. Maintaining consistent ball spacing is crucial for bearing performance, and the assembly line takes great care in this regard. A cage or separator is introduced to prevent ball contact, fitting it precisely to control ball movement. Finally, the cage is securely attached through riveting, ensuring long-term functionality. Power is transmitted from the turbine engines to the rotor through the main rotor gearbox. Within this gearbox, the bevel gear shaft plays a crucial role. It not only reduces speed but also ensures the operation of lubrication pumps. So, how is this intricate component crafted? The steel chosen for this purpose undergoes a vacuum remelting and heat treatment process, endowing it with exceptional mechanical properties. Before the actual manufacturing begins, the material undergoes preliminary quality checks. Every unprocessed piece, or blank, is marked with a batch number, ensuring the traceability of the raw material. Advanced gear cutting machines are employed to craft spiro-conical teeth, known for their robustness and precision. The niche riding process, often repeated, refines the properties of the meshing surfaces, enhancing the longevity of the parts. The teeth are crafted with a tolerance of just a few microns, ensuring a superior meshing quality and high reliability. Due to certain machining constraints, shaft bevel gears are crafted in two separate parts. These parts, the gear and vertical shafts, are then fused together using electron beam welding. This computer-monitored process, with its fine focus control, ensures the weld's precise positioning. The weld's quality is then verified using ultrasonic and radiographic techniques, confirming a robust and high-quality weld. Subsequent metallurgical inspections ensure the mechanical part's integrity, with various non-destructive testing (NDT) methods employed. Every component is stamped with a unique serial number, guaranteeing 100% traceability. The material used is held to the highest standards, with no impurities or surface defects allowed. Dimensional verifications are conducted with an accuracy of 1 micron, which is incredibly fine, 20 times finer than a strand of human hair. Before being sent to the assembly line, each part undergoes a final visual inspection. The bevel gear shaft is then integrated into the gearbox. During assembly, a quality inspector validates each step. The unique serial number of every bevel gear is logged to monitor its performance and key parameters like temperature and oil pressure. Once assembled, each gearbox undergoes rigorous testing. After passing these tests and being deemed flight-ready, the gearbox is paired with the rotor hub and sent off to the main assembly line. Following a series of thorough inspections, the aircraft moves on to flight testing, where its performance is evaluated in real-world conditions. For nearly a century, Lang & Sondermann, now known as AGTOS, has been a cornerstone in the production of springs for rail vehicles. Their specialty lies in the manufacturing of parabolic and coil springs. Integral to their manufacturing process is the art of hardening workpieces through shot peening, a critical step in ensuring the durability and performance of springs. AGTOS has incorporated 2 cutting-edge shot peening units from Octus to perfect this process. Let's delve into the intricacies of how these units transform raw materials into high-quality springs. Parabolic springs. After undergoing the crucial heat treatment process, the parabolic springs are in need of cleaning and descaling before shot peening. AGTOS Octus unit features a roller conveyor system that guides the workpieces through a closed loop, where loading and unloading occur at the same station. The workpiece carriers can accommodate 2 springs each, manually exchanged by operators as needed. Once in place, the springs are subjected to 20 tons of press force and a 200 mm upstroke, ensuring the necessary pre-tensioning. Sensors positioned along the conveyor automate the transport process, maintaining a feed rate of 3 to 10 meters per minute. As the springs pass through the unit, their tension sides and edges undergo surface hardening. Wear-resistant rubber curtains in the vestibules prevent blast media from escaping, while an accessible noise protection booth reduces noise levels. AGTOS relies on high-performance turbines to deliver precise hardening results, with blast media being released only after the workpieces have entered the blasting chamber. Coil springs. For coil springs, AGTOS employs a different shot peening unit designed to handle larger and heavier workpieces. Individual coil springs, ranging from 150 to 1,000 millimeters in length with a maximum diameter of 450 millimeters, can weigh up to 150 kilograms. These springs are transported to the unit's entry side using an indoor crane. A stair lift mechanism simplifies the loading process, and the unit can process around 60 springs per hour. Shot peening for coil springs involves not only cleaning but also reaching a hardness level of 40 HRC, Rockwell C scale. Two high-performance Actos turbines, each rated at 22 kilowatts, are responsible for this task. Unlike parabolic springs, coil springs arrive without prior cleaning. The unit's design ensures that both tension adjustments and the cleanliness of the springs are impeccably maintained. After shot peening, the springs are ready for subsequent processing, such as powder coating. Efficiency and environmental considerations. AGTOS prioritizes efficiency and environmental responsibility in its shot peening process. Dust generated during the operation is extracted and cleaned using an Octus SPF cartridge filter unit, keeping residual dust content below 1 milligram per cubic meter. This commitment allows them to recycle the exhaust air back into the production hall, conserving valuable heating energy. Industrial turbine services are crucial for maintaining and optimizing the performance of turbines used in various industrial applications. These services encompass a wide range of activities aimed at ensuring the reliability, efficiency, and safety of turbine systems, which are integral components in industries such as power generation, oil and gas, aviation, and manufacturing. One of the primary functions of industrial turbine services is maintenance. Regular inspections, cleaning, and repairs are essential to prevent unexpected downtime and costly breakdowns. These services involve the expertise of skilled technicians who can diagnose issues, replace worn-out components, and ensure that all parts of the turbine are functioning at their best. Turbine efficiency is a key concern for industries seeking to reduce operational costs and environmental impact. Industrial turbine services play a vital role in optimizing efficiency by conducting performance assessments, adjustments, and upgrades. This includes improving combustion processes, enhancing aerodynamics, and implementing advanced control systems to maximize power output while minimizing fuel consumption and emissions. Safety is paramount in industrial settings, and turbines can pose significant risks if not properly maintained. Turbine service providers prioritize safety by conducting thorough inspections and adhering to strict maintenance protocols. They also offer training and consulting services to help industrial facilities develop and implement safety procedures and protocols. Upgrading and retrofitting older turbine systems is another essential aspect of industrial turbine services. Advancements in technology and regulations often necessitate the modernization of turbines to meet current standards. Service providers can offer solutions such as retrofitting with more efficient components, implementing emission control systems, or converting turbines to use alternative fuels. Ethos Energy, a renowned industry leader, exemplifies excellence in providing a wide range of services that are essential for the optimal performance of these vital machinery. One of Ethos Energy's standout offerings is their expertise in the overhaul of GG4 and FT4 gas generators, as well as free turbines and other aeroderivative turbines. Houghton International has pioneered a breakthrough in coil insulation with its HiFLEX system. This state-of-the-art insulation solution is a composite of a fully cured film, mica paper, and an additional film layer. To enhance its mechanical robustness, the system incorporates unidirectional glass, which is bound together using an acrylic resin. This unique composition ensures both durability and reliability, making it a preferred choice for high-voltage applications. The rigorous testing protocol that HiFLEX undergoes is a testament to its superior quality. At the point of manufacture, each coil is subjected to comprehensive dielectric integrity tests. This ensures that every coil meets the stringent standards set by Houghton International. Additionally, the flexibility of the testing process allows for step-down tests both before coil insertion and throughout any repair processes. Such meticulous testing ensures that the coils are not only reliable but also adaptable to various operational needs. One of the standout features of the HiFLEX system is its end-winding flexibility. Despite being fully cured, the coils exhibit remarkable flexibility, especially in the coil extension or end-winding region. This is particularly advantageous in applications that involve large two-pole windings, in-situ rewinding, and skewed alternator coils. The system's design eliminates the need for post-winding procedures like baking, varnishing, or impregnation, streamlining the installation process and reducing operational downtimes. Storage and handling of the HiFLEX coils have also been optimized for longevity and ease. The coils are vacuum sealed in moisture-proof bags and then securely housed in robust wooden crates. This ensures that they remain in pristine condition during transit and storage. With a temperature rating of Class F 155 degrees Celsius, the HiFLEX system is suitable for applications that operate at voltages exceeding 6.6 kilovolts. Furthermore, Houghton International backs this innovative product with a warranty of up to 5 years, underscoring its commitment to quality and customer satisfaction. Overhauling one of Yukon Energy's hydro generators is a significant undertaking, as evidenced by ATCO Electric Yukon's multi-year major upgrade to its hydro generation facilities in the Fish Lake area, located on the western boundary of Whitehorse. Here's a summary of what the overhaul entails. The Fish Lake Dike was originally constructed in the late 1940s. After serving for over 6 decades, it was deemed necessary to upgrade the dike to meet current engineered standards and guidelines. The overhaul involved upgrading the Fish Lake Dike, diversion ditches, and power plant number 1. Jay Massey, who once worked as a summer laborer clearing beaver dams from the creek, is now the manager overseeing these The new power plant is notably more efficient than its predecessor. It can generate approximately 16% more power, which is sufficient to power around 250 homes. Power plant number 1 started its operations in 1950. In its early days, the plant had living quarters because it required constant maintenance. Replacement. The old plant, which was ATCO's sole hydro generation facility in Yukon, was replaced 3 years prior to the article's publication. It's worth noting that the majority of the electricity in the territory is supplied by the government-owned Yukon Energy Corporation. ATCO aims to transition its diesel plants in various locations, such as Watson Lake and Old Crow, to renewable energy sources. However, the current power plant's location limits its ability to serve isolated communities. The overhaul of the Whitehorse facility was estimated to cost between $7 to $8 million and was expected to be completed by the end of the month mentioned in the article. Forging is an ancient art of metalworking that has been practiced for thousands of years. It involves the shaping of metal using localized compressive forces, often delivered by a hammer or a die. The process not only changes the shape of the metal but also improves its properties by refining its grain structure. Over the years, several forging techniques have been developed, each with its unique advantages and applications. Among these techniques, open die forging, hammer forging, and ring rolling stand out due to their widespread use and significance in the manufacturing industry. Let's delve deeper into these processes and understand their intricacies. Seamless rolled ring forging is another fascinating process in the realm of metalworking. It begins with a thick, round piece of metal, typically punched to create a donut shape. This donut is then subjected to rolling and squeezing, or in some cases, pounding, to transform it into a thin ring. The seamless aspect of this forging ensures that the final product is free from any weak points or defects that could compromise its structural integrity. The versatility of this process is evident in the wide range of ring diameters it can produce. Rings forged using this method can be as small as a few inches in diameter or as large as 30 feet. Such a broad size range means that seamless rolled ring forgings find applications in various industries, from aerospace to energy and beyond. Open die forging, as the name suggests, is a process where the metal is not laterally confined by impression dies during forging. This allows for a high degree of flexibility in shaping the metal. The process typically involves working the starting stock progressively between flat-faced dies to achieve the desired shape. The open nature of this forging method means that the metal can be worked from multiple angles, allowing for a broad range of shapes and sizes. One of the most remarkable aspects of open die forging is its capability to produce extremely large forgings. These can range from a few pounds to an astonishing 150 tons or more. Such a vast size range makes open die forging an ideal choice for components that require optimum structural integrity. When the design criteria demand a massive metal component, the sheer size capability of open die forging often makes it a preferred choice over other non-forging alternatives. The only limitation to the size of an open die forging is the size of the starting stock or the largest ingot that can be cast. Step forging is a specialized forging process used to shape metal into complex geometries with multiple varying cross-sectional areas. Unlike traditional forging methods that uniformly shape the workpiece, step forging focuses on creating distinct steps or transitions in the metal, which correspond to different diameters or thicknesses. The process begins with a billet or workpiece that is heated until it becomes malleable. Once at the desired temperature, the metal is placed between forging dies that have been designed with the necessary recesses and protrusions to create the intended stepped profile. As the dies come together, they exert force on the metal, causing it to flow and fill the die cavities. This action forms the distinct steps in the workpiece. One of the primary advantages of step forging is its ability to produce complex shapes with high precision in a single or minimal number of operations. This not only reduces the overall production time but also ensures consistency in the final product. Moreover, step forging enhances the mechanical properties of the metal by refining its grain structure, leading to improved strength and durability. Hammer forging, often associated with the traditional image of a blacksmith striking metal with a hammer, is a process where the metal is shaped using repeated blows from a forging hammer. The hammer, which can be powered by steam, air, or electricity, delivers these blows onto the metal placed on an anvil or between dies. The force and frequency of the blows can be adjusted based on the requirements of the specific forging.
Das ist das Maß, was ich eingegeben habe, und das ist das Maß, was die Presse im Moment drückt. Ja, ist ja bald da, ne?
Kill steel, a name associated with quality and expertise in the forging industry, emphasizes the importance and versatility of these forging processes. Their approach to forging, as showcased in their video on the forging process, highlights the intricate details and the craftsmanship involved in transforming raw metal into functional and durable components.